Question 19, a right angle triangle is a bounds question. We're given two lengths correct to the nearest millimetre, and we're asked to calculate the lower bound for the size of the marked angle x. So we need the lower bound of x. So let's first of all work out the lower bound and upper bound of 9.3 and 12.6. Well, if it's to the nearest millimetre, that means the next one up will be 9.4 and the next one down will be 9.2. The lower bound and upper bound will be in between those values. So these will be 9.25 and 9.35. Similarly for the length 12.6, the lower bound will be 12.55 and the upper bound will be 12.65. Now x will be given by, because this is a right angle triangle, a soccer-turn relationship. We've got the opposite and we've got the hypotenuse, so that we can say that sine x is equal to the opposite over the hypotenuse. So because we're taking the sine of an angle and we want that angle to be the lower bound, is sine going to be the lowest value which matches that lowest value of x, if you know what I mean? Just a reminder of what sine gets up to. Sine climbs from 0 to 1 as it goes up from 0 to 90. So let's say our angle is here. We need the lower bound of the size of the angle, so we need x to be lowest. So for that, we need sine x to be lowest. So we're looking for the lower bound of sine x, which means we need the lower bound of the opposite and the upper bound of the hypotenuse. So let's put in those values. I can say that sine x lowest is equal to the lower limit of O, the opposite being the 9.3, so we want 9.25 here, divided by the upper bound of the longer length, which is 12.65. So therefore x will equal sine to the minus 1 of our fraction, and this is equal to 46.989, and on it goes. But given that our quoted lengths were only to 1 decimal place, I would say we needed to quote this to 1 decimal place. So therefore x is equal to 47, and that is to 1 dp. And that is your answer.